A multimillion-dollar hypercar is supposed to feel untouchable, built in isolation, engineered beyond comparison, and sealed off from anything ordinary. That is part of the mystique that surrounds machines like the Bugatti Chiron Sport. They are marketed not simply as cars, but as technological masterpieces that exist in a category all their own. For years, that image remained largely unquestioned. Yet the illusion began to crack the moment automotive YouTuber Mat Armstrong started dismantling a heavily damaged Bugatti Chiron Sport on camera. As he stripped away the shattered bodywork and exposed what lay beneath, viewers were stunned to discover components that appeared remarkably familiar, including parts connected to the Volkswagen group. Suddenly, the conversation shifted from admiration to curiosity. How much of a multimillion-dollar hypercar was truly unique? And how much was shared with the corporate family that owned Bugatti at the time? The answers would spark one of the most fascinating automotive rebuild stories ever documented online. The car at the center of the controversy was no ordinary Chiron. It was a Bugatti Chiron Sport, one of only around 60 examples ever produced. Created during Bugatti's Volkswagen Group era, the Sport represented a more aggressive and driver-focused evolution of the already extraordinary Chiron platform. Its 8-liter quad-turbocharged W16 engine generated roughly 1,500 horsepower, but raw speed was no longer the sole objective. Engineers revised the gearing, suspension, aerodynamics, and weight distribution to create a machine that felt sharper, more responsive, and more capable through corners. With a price exceeding $3.5 million before personalization, the Sport occupied a realm where engineering excess itself became a selling point. One of those rare cars belonged to Florida-based influencer Alex Gonzalez, known online as FXLXG. By 2024, the Sport had become a familiar sight across social media platforms, appearing regularly in videos, online content, and public automotive events. The car symbolized status, exclusivity, and success. Yet the same visibility that amplifies prestige also magnifies failure. Hypercars attract attention from every angle, and when something goes wrong, the world notices. The crash that changed everything was surprisingly ordinary. There was no dramatic racetrack accident, no high-speed highway run gone wrong, and no spectacular loss of control. Instead, traffic slowed unexpectedly. Braking rippled through the vehicles ahead. A chain reaction followed, and the Bugatti became involved in a violent impact. Despite being rear-ended, the Sport suffered catastrophic front-end damage. Carbon fiber body panels shattered, aerodynamic structures collapsed, suspension geometry was compromised, and critical systems were damaged almost instantly. The destruction extended far beyond cosmetic concerns. Even the headlights alone represented an enormous financial loss, while deployed airbags confirmed that the accident had escalated into something far more serious than a simple fender bender. A Bugatti technician was flown in from Europe to inspect the vehicle personally. The evaluation followed the same principles used throughout the luxury insurance industry. When repair costs approach or exceed certain financial thresholds, even exceptionally rare vehicles can be declared economically impractical to restore. The Sport's rarity offered no protection from that reality. After a detailed assessment, the hypercar was officially written off. It entered the salvage system and eventually arrived at Copart, where damaged exotic vehicles are auctioned to buyers willing to take enormous risks. For most cars, that would have marked the end of the story. Instead, it became the beginning. After receiving the insurance settlement, Alex Gonzalez purchased the wrecked Bugatti back himself. Reports suggested the repurchase cost approximately $1.6 million before additional auction fees pushed the total even higher. On paper, the decision appeared irrational. He had effectively spent millions of dollars to regain possession of a vehicle that many experts considered financially hopeless. Yet the project would soon take on an entirely different dimension when Mat Armstrong entered the picture. Armstrong had already built a large audience by rebuilding heavily damaged performance vehicles. His channel documented complex restorations that many believed impossible. However, a Bugatti Chiron Sport represented a challenge on an entirely different scale. This was not a damaged sports car waiting for replacement panels. It was one of the most sophisticated road-going machines ever constructed. The vehicle relied upon an advanced carbon fiber monocoque, microscopic manufacturing tolerances, intricate cooling systems, and a drivetrain so complex that few independent workshops had ever attempted significant repairs. The damage extended deep into the heart of the car's architecture. Structural sections at the front were compromised. Lighting systems were destroyed. Mounting points had shifted. Questions emerged regarding the integrity of the carbon fiber tub itself. In a vehicle like the Chiron, the monocoque is effectively the car. Every major component connects to it. If that structure is damaged beyond acceptable limits, repairs move beyond traditional bodywork and enter the realm of advanced engineering reconstruction. To many observers, the conclusion seemed obvious. The car was finished. Bugatti's own service philosophy reinforced that perception. The company maintains a highly controlled repair ecosystem built around factory-approved facilities, specialized technicians, and tightly regulated procedures. Outside that network, restoring a severely damaged Chiron per sport was viewed as unrealistic. Yet Armstrong approached the challenge differently. Rather than accepting conventional wisdom, he began dismantling the vehicle piece by piece, determined to understand exactly what remained salvageable and what would need to be recreated. As the rebuild progressed, a new obstacle emerged. The greatest challenge was no longer the crash damage itself. It was access to parts and support. Bugatti declined to participate in the restoration and would not provide official replacement components through normal channels. In the hypercar world, this changes everything. Vehicles like the Chiron do not operate within a traditional aftermarket ecosystem, where parts can simply be ordered when needed. Nearly every major component is controlled through manufacturer networks linked directly to the vehicle's VIN. That VIN soon became the center of controversy. According to details discussed throughout the rebuild process, the car's identification status had effectively been restricted within Bugatti's internal systems. Once that occurs, authorized dealers can no longer process parts requests or perform standard factory-backed servicing as they normally would. The vehicle still physically exists, but within the manufacturer's infrastructure it occupies a very different category. The conventional restoration pathway involving dealer support, factory ordering, approved repairs, and official oversight effectively disappears. The rebuild suddenly found itself operating completely outside the manufacturer's ecosystem. That reality created significant technical and philosophical questions. The Chiron is not constructed like an ordinary automobile. Its carbon fiber monocoque forms the foundation of the entire machine, integrating crash protection, suspension geometry, drivetrain alignment, and structural rigidity into a single shell. Repairs involving such a structure require extraordinary precision. Even small deviations can influence aerodynamics, chassis balance, stress distribution, and stability at extreme speeds. Public skepticism intensified when Mate Rimac questioned whether a rebuild of this magnitude could realistically achieve factory standards outside Bugatti-controlled facilities. His concerns centered on engineering precision and safety. A hypercar capable of approaching 300 miles per hour is not something manufacturers want rebuilt through trial and error. From Bugatti's perspective, operations involving monocoque inspection, chassis separation, and structural realignment require specialized equipment, calibrated measurement systems, dedicated fixtures, and technicians trained specifically within the company's own environment in Motium, France. Even microscopic alignment discrepancies could theoretically become dangerous at very high speeds. Yet Armstrong and his team viewed the situation differently. To them, the Chiron remained a machine. It was extraordinarily complex, certainly, but not beyond human understanding. Rather than relying upon factory channels, they pursued independent solutions. Damaged sections would be fabricated. Components would be sourced creatively. Systems would be reverse engineered. Problems would be solved one at a time. This conflict transformed the project into something larger than a salvage rebuild. It became a public debate about ownership itself. How much control should a manufacturer retain after a customer legally purchases a vehicle? Can a company effectively lock a multimillion-dollar car out of its support network following a major accident? And if skilled engineers successfully restore that vehicle independently, who determines whether the repair is legitimate? These questions unfolded before millions of viewers online. The workshop in Miami that received the wrecked Bugatti was never intended to perform factory-level hypercar reconstruction. There were no original Bugatti jigs, no manufacturer fixtures, and no direct technical pipeline connecting the team to the factory. What emerged instead was a parallel engineering effort built from the ground up, without official support. The project evolved from a standard repair into a full-scale reconstruction exercise. Traditional hypercar servicing depends heavily upon manufacturer-controlled supply chains. Structural components, drivetrain assemblies, electronic modules, and specialized hardware normally arrive through official channels. In this case, those channels were unavailable. The only viable path forward involved recreating missing functionality through reverse engineering, fabrication, and independent sourcing. Digital reconstruction became a cornerstone of the process. Damaged components were scanned at high resolution to generate accurate three-dimensional models. These models effectively replaced factory blueprints and served as a foundation for manufacturing replacement parts. Computer numerical control machining translated those digital files into physical components with tolerances precise enough for high-performance automotive applications. Such techniques are common within aerospace and professional motorsport environments where original parts may be unavailable, but precision remains non-negotiable. One of the most dramatic stages involved separating the chassis. The vehicle was split to access internal assemblies, including drivetrain mounting structures and transmission housing areas that had absorbed substantial crash forces. Even among supercars, this is not a routine procedure. Once opened, the Chiron revealed the extraordinary complexity of its internal architecture. The integration between systems and the carbon fiber monocoque became immediately apparent. Attention then shifted to the gearbox mounting structure. This area governed alignment between the engine, transmission, and chassis. Any distortion can affect drivability, mechanical longevity, and high-speed stability. Rather than replacing complete factory assemblies, the team focused on structural rehabilitation. Load paths were analyzed. Damaged sections were reinforced. Critical geometry was restored. The goal was not merely to replace components, but to recover the functional integrity of the original design. Custom fabrication soon became essential. The cooling system provided one example. Several radiators had been destroyed during the accident, yet thermal management is critical to the Chiron's performance. Rather than waiting indefinitely for factory components, replacement units were engineered and produced to meet required performance specifications. Function became more important than branding or official origin. Interior and safety systems presented similar challenges. Certain parts, including airbags and trim pieces, required alternative solutions when genuine replacements could not be obtained through restricted channels. The interior was reconstructed to
restore its original appearance and functionality, even if some underlying components originated from non-factory sources. Throughout the project, the focus remained on achieving operational performance rather than absolute OEM purity. Perhaps the most complicated challenge involved